Okay, this is chapter 13 of Fred, and the chapter is called Before 4. Okay, it is 3:05. Okay, and Fred has 55 minutes until his conference, the math and pizza conference, begins, and he's expecting a bunch of people. He already has 50 people who have showed up. Some of the people are Fred's students. Darlene and Joe are there. Joe always gets there early when pizza is involved. Fred introduced himself to some of the people he didn't know. Okay, so here's some of the people. There was a couple who were math professors, and they were at one of the big California universities. They had their little kids with them, but we can't see them in the picture. And the wife, math professor, she invited Fred to sit with them. And she said to him, then you could have someone to play with during the keynote speech. Obviously, she didn't know he was the speaker. She thought he was just a 5-year-old and might want to play with his kids. Fred didn't tell her that she was wrong. All he mentioned was his name, which was Fred, and he was 5 years old. He didn't want people to think he was only 4. We wouldn't want that. There were math teachers from Germany, France, and Poland. There was a woman who was a famous pizza chef from Italy. And this famous pizza chef from Italy, she told Fred she wanted to learn how Stanley Anthony's pizza was world famous. Fred introduced her to Stan Anthony, and she spoke to him in Italian, thinking, with a name like Stanley Anthony, Michelangelo do Lodovico Buonarroti Simone, he must have grown up in Italy. Fred didn't understand a word she was speaking, and neither did Stanley Anthony. Some of the conversations that Fred overheard was about category theory, linear functionals, homomorphisms, and more. Sounds like fascinating conversation, right? And of course, kids were running around everywhere. And on the television set was a Marx Brothers movie. You ever watched one of their little shows? Fred thought this made Pie 1 actually authentically Italian. I don't know. Now, Fred needed a place where he could be alone for a few minutes before his speech. So he climbed up on top of his green machine. I guess I should have made this green instead of red. We'll just color it green. This is his big green machine. And he looked down over the crowd, and this made him feel very tall. But Fred wondered, am I forgetting something? Fred had his pink bow tie, and it was straight. His brown shoes were polished. He had all the ingredients for making ice cream. There's only 2 minor things that Fred had forgotten. So the 2 things that he had forgotten to do was, 1, he couldn't operate the ice cream machine, the ice cream maker, and 2, he never wrote his speech. So he spotted a little booklet that was taped to the top of the ice cream maker. He never would have found it if he hadn't climbed to the top. So here's Fred on top of the ice maker. This is the ice maker, and this is a piece of paper that's taped on top of the big green machine. It's the instruction manual. And the first thing he needs to do is plug it in. Okay? So he climbed down and plugged in the electric cord. 2, he needs to pull down on the freezing level to set the coolness. So here's a lever, and he will pull that down. So he has to pull down the lever. And there's a warning. It says, the lever is on a spring. Press harder to make it colder. Well, Fred doesn't really know what that means, but he looks at the lever, and on the lever, there's some instructions. So looking at the lever, Fred sees there's the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there's this is not too cold, medium cold, fairly cold, cold, and cold beyond belief. Finish writing it there. Okay. Now, Fred pulls down on the lever with 1 pound of force, and the lever moves to 3. Okay. Then he pulled down with 3 pounds of force, and it goes to 6. Now, Fred didn't want to overdo it. He figured that moving the lever all the way down to 9 would be perfect. So he pulls it down there, and he had 2 pieces of information. 1 pound moved the lever to 3. 3 pounds of force moved the lever to 6. And at this point, he's got what? Okay. So we have 2 ordered pairs. We have 1 ordered pair is 1 pound of force moves the lever down to 3. 3 pounds of force moves it down to 6. And we can make a graph with these ordered pairs. We could have, hang on, over here we could write 1, 2, 3, 4, 5, 6, 7, let's say. Over here, 1, 2, 3, 4, 5, 6, 7. And we have right here 1, 1, and 3. So that would be 1 ordered pair. That's this one right here. And then we have 3 and 6, which is 3. Here's the 3 and 6 would be right here. So this is 1 and 3. This is 3 and 6 because we're above the 3 and level with the 6. And we also can mark this as this line being X and this line being Y. That's the X value and that's the Y value. And we can draw a line through our pairs. So we drew a line through 2 dots. Okay, so there's an interesting fact. In Fred's high school physics class, how old do you think he was when he was in high school physics? Because he's already a college professor. Fred learned about something called Hooke's law. And so Hooke's law means this: how far a spring stretches is proportional to how hard you pull it. So if I translate that, when you graph the pull and where it lands, it's always going to be a straight line. And so if you go back and look at my chart I made, when I plotted the dots, it makes a straight line. That's what Hooke's law is. How far a spring goes, how much force you use, it's proportional. So it always makes a straight line. Okay, so your turn to play. So here's the first question. You can look at my graph here. Our first set of ordered pair was 1 and 3, which is 1 right here and 3 right here. Our second ordered pair was 3 and 6, and that was 3 and 6 right here. I guess I didn't make my line very straight. And so what would be the next ordered pair that you would see? What would it take to get to 9? So you need to figure out what number goes there. Okay? Okay, for the next number 2, on a piece of paper, graph these ordered pairs: 2 and 5, 4 and 3, and 8 and 1. And then after you draw a graph like I just did before, then you have to answer yes or no. Are these 3 points on a straight line? So are those 3 points on a straight line when you draw it on your graph? Okay. So the slope of the line, that's this part right here, the part that's going up, is defined as rise over run. And we have the rise and the run, and this is the slope. So slope equals rise divided by run. Okay? Okay, so I'm showing my slope right here, and this part up and down here is the rise, and this is the run. The formula is slope equals, so I'm trying to figure out what this is. Slope equals rise divided by run. And again, slope equals rise divided by run. Both of these say the exact same thing. I just said it differently. Okay, so this is what is the slope of this line right here. So we're trying to figure out what this slope is. We know the rise is 32 and the run is 16. And I've already told you that you need to divide 32 divided by 16. And so what does that equal? So you can set your problem up in several ways. You could do 16, okay, 32 divided by 16. You could write it 32 divided by 16, but you're still going to have to get it to look like that. Okay, so you do this division. If this is hard for you, then try to then work it out this way. 16 times 1 equals what? 16 times 2 equals what? 16 times 3 equals what? And then one of these answers will be, will tell you, you'll get that number on. You'll get 36 as the answer. So work that out. And then you'll be able to tell me what this answer is and what the slope is. Okay? So the slope is 32 divided by 16, and the answer goes right here and tells me what this line is. Okay. After you have done the other 3 questions, for 4 you need to work on your honey cards or finish taking your multiplication tests if you didn't get all the way through the 12s and the multi numbers.